Welcome to this Skill Builder session on means for expressing strengths of solutions. In this session, we'll be looking at different ways of expressing strengths of solutions. First, we'll look at metric prefixes and units and suffixes. Then we'll look at percentage strengths, ratio or part strengths, and amount strength. Please note that this session won't deal with molarity. The session is intended primarily for biology, chemistry and medicine and pharmacy students. The metric system uses prefixes for multiples and submultiples of units. However, the prefixes for equivalent weights and volumes within the metric system do not correspond. So, for example, we can see that milliliters correspond with grams, not milligrams. Rather, microliters correspond with milligrams, nanoliters with micrograms, and so on. The next thing we need to bear in mind is that percentage and ratio or part strengths must always be expressed in corresponding units based on the nature of the dilution or mixture. So, when dealing with a liquid in a liquid, this would be milliliters per milliliter, microliters per microliter, liters per liter, and so on. Similarly, for a solid in a solid, this could be milligrams per milligram, grams per gram, kilograms per kilogram, and so on. However, when we have mixtures of solids and liquids, corresponding units will not have corresponding prefixes. So, for example, a solid in a liquid might be expressed as grams per milliliter, milligrams per microliter, micrograms per nanoliter, and so on. Similarly, a solid in a liquid might be expressed in terms of milliliters per gram, microliters per milligram, kilograms per liter, and so on. In order to help us identify the nature of the substance and the base or diluent, percentage and ratio or part strengths are generally suffixed. This takes the form of two letters, V for volume of a liquid and W for weight of a solid. So, a liquid in a liquid will be suffixed VV, a solid in a solid WW, a solid in a liquid WV, and a liquid in a solid VW. So then, a percentage strength represents the number of units of a substance contained in 100 corresponding units of a solution or mixture. For example, an antiseptic cream contains 1.2% weight in weight of phenol. Applying appropriate units, we could express this as 1.2 grams in 100 grams. We can then use straightforward multiplication to calculate how much phenol is contained within a 30-gram tube of antiseptic cream. 1.2 grams over 100 grams times 30 grams to give us a final value of 0.36 grams. Ratio or part strengths can be expressed in two ways. Firstly, as a ratio or part strength that represents the number of units of a solution or mixture that contains one corresponding unit of a substance. For example, an IV solution contains glucose 1 in 20 in water. Applying appropriate units, we could say that this is equivalent to 1 gram in 20 milliliters, glucose being a solid ingredient. And once again, we could use straightforward multiplication to calculate how much glucose is contained in a 500 milliliter IV bag, 1 part in 20. 1 gram over 20 milliliters times 500 milliliters to give us a final value of 25 grams. The second way of expressing a ratio or part strength is as the number of units of a substance contained in a standard number of corresponding units of a solution or mixture. For example, acetonitrile contains less than 30 parts per million of H2O. Applying appropriate units, we could say that this is equivalent to less than 30 milliliters in 1 million milliliters. And once again, we can use straightforward multiplication to calculate the maximum amount of H2O contained within a 2.5 litre carboy of acetonitrile. 30 millilitres in 1 million millilitres times 2,500 millilitres to give us a final value of 0.075 millilitres. Lastly, amount strength. An amount strength represents the number of units of a substance contained in a number of units of a solution or mixture. Unlike a percentage or part strength, an amount strength does not have to be expressed in corresponding units. For example, a mineral water contains sodium 32 milligrams per litre. In this case, we can simply use the units specified in the amount strength, 32 milligrams per 1 litre. However, if we want to calculate how much sodium is contained in a 750 millilitre bottle of mineral water, we'll find it easier to convert litres to millilitres. This will now give us 32 milligrams in 1000 millilitres times 750 millilitres for a final value of 24 milligrams. Thank you for watching this Skill Builder session on means for expressing the strengths of solutions. If you'd like to follow up on any of the topics covered, please follow the QR code to book a one-to-one appointment with either a student learning advisor or, for support with more advanced topics, our Maths and Stats Clinic.